this problem, we have a set of 4 capacitors. They're attached in a circuit. Initially, the switch is open, so that means no current would flow through here, no charge would flow. And there's an applied potential difference across points A and B of a positive 210 volts, which means A is at a high potential and B is at a lower potential. First question is, what is the potential difference between points C and D? So let's start to figure that out. First thing we'll do is let's figure out the potential on each of the capacitors. That'll give us a tool to find out the potential difference between points C and D. So to figure out those potentials, let's start with an equivalent circuit. Let's redraw our circuit with the switch open, which is the same thing as not even having a branch in the circuit right here. So here's point A, goes up to the first capacitor, goes to the second, and then down on the bottom goes through the 2 capacitors. C1 equals 3 microfarads, C2 equals 6 microfarads, C3 is 6 microfarads, and C4 is 3 microfarads. What we see in this circuit is that 1 and 2 are in series, 3 and 4 are in series, so we can find the equivalent of these. So these are a series connection, which means 1 over C equivalent is 1 over 3 microfarads plus 1 over 6 microfarads. 1 over 3 is 2 over 6, 2 over 6 plus 1 over 6 is 3 over 6. So then our equivalent capacitance is 6 microfarads over 3, or 2 microfarads. On the bottom we have exactly the same thing. They're a series connection. They're 3 and 6, so the equivalent capacitance is going to be 2 microfarads. Okay, let's redraw that circuit. So points A and B, 2 equivalent capacitances of 2 microfarads and 2 microfarads. What can we figure out here? Well, we know that the potential difference between points A and B is 210 volts. So the potential across this guy is 210 volts, and the potential across this guy is 210 volts. If we know both of the potentials, we can find the charges. So Q, which is capacitance times potential, is 2 microfarads times the potential of 210 volts. Do that through the calculator, we get 420 microcoulombs. And likewise down here, well, what can we do with this information? Let's back up to this picture. This is a series combination of these two, which means the charge in each of these is also 420 microcoulombs. Likewise down here, this is a series combination where the charge is 420 microcoulombs. So the charge on each of these is 420 microcoulombs. You can go ahead and add this to this picture if you wish, or you can start with a fresh picture just to make sure things don't get too cluttered. So I'm going to back up my picture and I'm going to redraw the original circuit. So there's my original circuit. I'm going to write down the things that I know. C1 is 3 microcoulombs, is 3 microfarads. My charge Q is equal to 420 microcoulombs. So I can find the potential across C1. I won't write it in right here, but V1 is equal to Q1 over C1, 420 microcoulombs, divided by 3 microfarads, gives me a potential across this capacitor of 140 volts. And And let's do the other capacitors as well. This is C2, which is 6 microfarads. It has a charge of 420 microcoulombs. So V2 is Q2 over C2, 420 microcoulombs, divided by the capacitance of 6 microfarads to get a potential of 70 volts. And then we can come to our capacitors in the bottom branch. This capacitance C3 is 6 microfarads. C3, the charge is 420 microcoulombs. So the potential is charge divided by capacitance, 420 microcoulombs over 6 microfarads to get 70 volts. And then for this capacitor, C4 is 3 microfarads, charge is 420 microcoulombs. Potential is charge over capacitance, 140 volts. Okay, and now let's label in some other things in this picture. This is point A. This is point B. The potential between A and B is plus 210 volts. The plus is kind of important. It means that the potential at point A is higher than the potential at point B. So right here at point A, this is a high potential. And at point B, this is a low potential. So what that means is as we come through this branch, so if we come down around this way, our potential of 140 volts here must be a drop. And our potential of 70 volts here must be a drop. So to go from A to B, we decrease by 210 volts because we come from high to low, so we have to go down by 210, which makes this a drop and this a drop. As we go from B back to A, our potential has to increase, so we go from low to high. So our potential of 140 volts here must be an increase. And again, our 70 volts here is an increase. And together, they increase us back up to 210 volts. Okay, so now we've thought about which way the potentials are changing. Where are they a high potential and where are they a low potential? Now let's get to the question we're asked. What's the potential difference between these points? So our delta V between those points is we start at D, we drop by 70. So we're going to say negative because we're dropping. And then we come around to this capacitor where we increase by 140. So our total potential difference is a decrease of 70, an increase of 140. So overall an increase of 70 volts. So there's our potential difference between points C and D. In the next part, we'll find what's the potential difference across each capacitor after we close that switch.